Here's every main part of a computer explained simply. First, the motherboard. It's the large, flat board inside your PC filled with circuits, slots, and connectors. This is where every major component, the CPU, RAM, storage, graphics card, and power supply all come together. The motherboard works like the backbone and nervous system of the computer. It doesn't just hold parts in place, it allows them to communicate through electrical pathways called buses. By connecting everything, the motherboard makes the entire system function as one computer. Next, the CPU, Central Processing Unit. It's a small, square chip that sits on the motherboard, often covered by a cooling fan. People call it the brain of the computer because it handles instructions and calculations for every single task. In the early days, CPUs like the old Intel Pentium series had just one core, meaning they could only process one instruction at a time. If you opened too many programs, the computer would slow down because that single core had to juggle everything. Modern CPUs, however, have multiple cores, sometimes 4, 8, 16, or even more. Each core can work on a different task, so the computer can multitask much more smoothly. That's why modern processors feel faster, even if their clock speed, gigahertz, isn't extremely high. Now let's talk about RAM, Random Access Memory. It's a slim stick that plugs into the motherboard, and it acts as the computer's short-term memory. RAM stores the data your CPU needs right now. Things like open apps, active files, or processes you're currently working on. The more RAM you have, the easier it is to run multiple programs at once without slowing down. For example, if you're editing a photo while keeping your browser and music player open, more RAM allows everything to stay responsive. But when the computer shuts down, RAM clears itself, so any unsaved work is lost. Now let's talk about storage. This is where all of your data lives long-term. Your operating system, programs, photos, videos, games, and personal files. Unlike RAM, storage keeps everything even when the computer is turned off. The traditional option is the hard disk drive, HDD. It uses spinning magnetic disks and a small mechanical arm to read and write data. HDDs can hold large amounts of data for a low price, but they're slower because of their moving parts. A faster option is the solid-state drive, SSD, which uses memory chips instead of spinning parts. This means data loads almost instantly. Your system boots faster, programs open quicker, and everything feels more responsive. And then there are NVMe SSDs, which connect directly to the motherboard for even greater speed. If you want top performance, this is the storage type to look for. Next, the GPU, Graphics Processing Unit. At first, GPUs were built mainly to handle graphics, rendering 3D games, playing videos, and producing visuals on your screen. That's why gamers and video editors depend on powerful GPUs. But a GPU isn't only for visuals. It's actually a processor designed for parallel calculations, meaning it can perform thousands of smaller tasks at the same time. This is very different from a CPU, which is optimized for fewer, more complex tasks. That ability to process massive workloads in parallel makes GPUs extremely useful beyond gaming. Today, they're used in AI and machine learning, where huge amounts of data need to be processed quickly. They're also critical in cryptocurrency mining, scientific simulations, and even medical research. So while the CPU is still the general-purpose brain of the computer, the GPU has evolved into a specialized powerhouse that fuels gaming, creativity, AI, and even future technologies. Besides the CPU, GPU, RAM, and storage, there are also other components. For example, older computers often needed separate cards for things like Wi-Fi, network cards, or sound. But today, most of these are already built directly into the motherboard. And that brings us back to the motherboard itself. It's the central place where all of these components come together to form the complete computer system. All of this hardware is placed inside the case. The case doesn't just protect the components, it also organizes them and helps with airflow. Since everything is closed inside, we need cooling. Cooling usually comes in the form of fans that push hot air out and bring cool air in. High-performance computers sometimes use liquid cooling to handle the extra heat from powerful CPUs and GPUs. Of course, none of these parts can work without electricity. That's where the power supply unit, PSU, comes in. The electricity from your wall is AC power, alternating current. But computer components need DC power, direct current, at specific voltages like 12 volts for the CPU and GPU, 5 volts for USB ports, and 3.3 volts for the motherboard circuits. The PSU's job is to convert AC into stable DC power and send the correct amount to each component through different cables. That's why choosing a PSU with the right wattage and efficiency rating is so important. It ensures your system runs reliably and safely. So now the case is ready, with all the parts inside, powered and cooled. The only thing left is to connect your monitor, keyboard, and mouse. All of these components play a role in making your computer run. If you found this helpful, don't forget to subscribe for more tech breakdowns.